Welcome to this presentation and thank you for tuning in. The focus is on the Bombay group. The phenotype is usually written as OH, O sub H, and then the genotype is usually written as H, small h, and another small h, or if you prefer the big H, you say null, meaning that it does not have the big H. This HH comes from the inheritance of two recessive genes. Now, the Bombay phenotype or blood group was first discovered in 1952, which is some 64 years ago, by one Dr. Y.M. Bender. He made this discovery in Bombay, which is present-day Mumbai. Now, the thing that you need to know about this is that this is an extremely rare ABO blood group. And it's so rare that even in the Bombay community, the incidence will be something like 1 in every 10,000 people, which will translate to something like 0.1% of the population in Mumbai. And it even goes further to have an incidence of, say, 4 in every 1 million people, which is approximately something like 0.004% globally. So when you talk about the Bombay blood group, you talk of a blood group that is extremely rare. You may never even encounter this in your regular practice, and this is why I have chosen this topic, because it fits into the review topics I usually refer to as outliers. You may never encounter it, like I said, but you will have to anticipate it in the exam. Now, one thing about this blood group is that it can be easily misdiagnosed in the laboratory if and when it does show up as a group O. Take a look at this table. This patient 1 here tested negative with anti-A in the routine forward grouping, negative anti-B, negative with anti-AB, and so presented as group O. Same thing with the reverse grouping. Here you have it as 4+ with A1 cells and 4+ with B cells. You get the same picture here with a Bombay with patient 2. So this is something that is noteworthy, not only for the exam, but in regular practice when you have a group O blood. Now, let's get straight into what you need to know regarding the exam. Let us say you have a red top. Let's designate that this way. And in this red top, the blood is from a Bombay individual. Here is your blood. When you process this, you will get the red blood cells down here, and then you will have your serum this way. Now here is what to know, all that parts you need to know for the exam. Number 1, that this Bombay serum contains anti-A. It also contains anti-B. It also contains anti-AB, and finally it contains anti-H. Okay? Now the red cell, on the other hand, the Bombay red cell, is remarkable in the sense that it does not have any antigens on its surface. In other words, it's devoid of the normal ABH antigens. So if it does not have the ABH antigens, it simply means that it will not agglutinate with anti-A. So you say no agglutination. With anti-A serum. Okay, there will be no agglutination with anti-B too. There will be no agglutination with anti-AB, and there will be no agglutination with anti-H. So in a nutshell, this is what to expect when you have a question. No matter how it is twisted, you will be able to answer that question based on your knowledge of what happens when you separate this specimen. Because the questions could be focused on this serum, a patient serum that is known to be a Bombay blood group, or the red cells. For example, let's take a few examples. If we have the patient cells, which are these here, and you react them with anti-A serum, there will be no agglutination because there is nothing here to react with the anti-A. By the same token, if you react it with anti-B, there will be no reaction. And if you also react it with, let me give you an example of something that will be confusing here. We already know that there's nothing here. So if we react it with Ulex, Europaus, you will say, what is this? And then you probably will be thrown off. Well, Ulex is not something, it's not a reagent you encounter that often. However, it's some reagent you need to know. You probably know it by its common name. It's simply the anti-H lectin. It's a reagent anti-H which is produced from the seeds of the plant Ulex eurepus. So, when you have the patient cells and you react with Ulex eurepus, there will be no agglutination. Now, here is a trickier, question. What if you reacted the patient's serum with a group O donor cells, knowing that the group O donor cells, from your knowledge of the group O, it doesn't have the A antigen, doesn't have the B antigen. You are reacting this Bombay serum with a group O donor cells. What do you expect? Agglutination or no agglutination? Well, let's look at it this way. First of all, there will be agglutination. And why is it? Here is the reason. We know that the group O blood has the highest concentration of the H antigen. In fact, the group O in this order has more H antigen than group A2 and it has more H antigen than B in this order, and then the A2B, and in this order the A1, and then with the least amount occurring in the A1B. So the group O has a lot of the H antigen, either the HH or the H, this as the genotype. So what that simply means is that the group O individual is likely to react because the H antigen is what is going to react with the Bombay antiserum. And keep in mind, the Bombay antiserum has an anti-H, a very potent anti-H which has a wide thermal range. So it will react with this H from the group O individual. That is why the donor cells from the group O would react with the Bombay serum. So the key thing here is to know what to expect in the serum and realize that the Bombay red cells do not have any antigens. Now this has some implication in blood transfusion, in the sense that only blood from a Bombay donor can be transfused to a Bombay recipient, and that's something also to watch out for in the exam. I just can't give you a specific set of questions, but once you know the basic facts about what I have just diagrammatized here, you will be able to deal with the questions that may arise irrespective of the nature of the question. By the way, I earlier mentioned ULEX, Eurepus, and then I also indicated that this is simply anti-H. Now that we have known that, it is also perhaps pertinent to point out another lectin seed extract that could be thrown into the mix in an exam. That one I'm sure you have encountered before is called Dolichos biflorus. It's a source of anti-A1. Okay, so keep in mind that when you are looking at the Bombay group, you make a note of these uncommon extracts and then see how they can play into the mix. And that's the end of the presentation. Good luck in your exams.